Here, last class we have studied about the factors affecting the resistance as well as what is the difference between the resistance and resistivity. Okay, resistance is nothing but the resistance to the flow of charge electrons, right? But resistivity is the same thing, resistance to the flow of charges, but for a particular dimension. What is the dimension? For 1 meter length and the cross section area should be 1 meter square for a particular dimension. Okay, so today we'll learn about some of the facts. Okay, they are given the resistivity of metals and alloys. In the book they have given some of the resistivities of alloys, metals, insulators, everything. Okay, conductors, alloys and insulators. Okay, they are given the resistance value at the at 20 degrees Celsius. Okay, no need to memorize all this value, but you should at least know what is the range of this resistivity for metals and insulators and all. Okay, that we will learn, and based on that values we will have some conclusion, right? So the resistivity of the metals and alloys, it has low resistivity. Okay, the metals and alloys have a low resistivity. So that means what? It is a good conductors of electricity. There is low resistivity means there is these are the good conductors of electricity, right? So what is the range of the resistances? It ranges from 10 to the power of minus 8 ohm meter. This is an ohm meter means that nothing but the resistivity, right? It ranges from 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter. Okay, ohm means resistance, and ohm meter they given, that mean that is one, that is resistivity. Okay, per unit length. Okay, when you see the look at this tabular column, you can find that resistivity of the alloy is higher than its constant metals. Okay, if you see this, see these are the alloys value. When you compare with this, the resistivity is more for this alloys when compared to the metals. For example, the alloys the alloys of nickel, chromium, manganese, iron is nichrome. Okay, that resistivity of this thing is 100 into 10 to the power of minus 6. Okay, when compared to this nickel, see nickel, it is 6.84 into 10 to the power of minus 8. Okay, the resistivity is very low. Here it is high resistivity. Alloy has high resistivity. Okay, resistivity of the alloy is higher than its constant metals. Okay, next, some uses of some substance based on its resistivity. Okay, you know that alloy has the more resistant when compared to the metals. Okay, so alloys are commonly used in electrical heating devices. What are the electrical heating devices you have seen in your day-to-day life? Electric iron box, toaster, etc. Okay, so why it is used in these heating devices means it has very high resistivity when compared to its constant metal. They will not use the metal directly. Okay, they use the alloy instead of metals. They will use the alloy because it has higher resistivity. And one more thing is, it does not undergo oxidation. It will not burn easily at very high temperature. Okay, you are use this iron box and all, right? So it does not undergo oxidation. It will not burn easily. Okay, easily at higher temperature. For these two reasons they are using in the electrical heating devices. Okay, then copper and aluminum has less resistivity, right? Low resistivity. So it is used for electrical transmission line. Okay, it is used in the transmission line, the copper and aluminum. Okay, next, tungsten is used almost exclusively for filaments of electric bulbs. If you have seen this bulb, they usually shown the bulb by the strings, right? This is nothing but the filament, right? It will be like this, right? It will be like that. This is called a filament that is made up of tungsten. Okay, if you have seen this, it is coiled. It is very very thin in nature. Okay, the tungsten is used almost exclusively for the filament of the electrical bulb because of its high melting point. It has high melting point because the energy carried by the electrons are converted into heat and light energy at this place, right? So it has to withstand a very high temperature. So tungsten is used there because it has a high melting point. Okay, it has a very high melting point, and the resistivity is low only. When you look at the book, the resistivity is low. When you look at this table, see, aluminum and copper is used for transmission line, and you are having only slightly higher value when compared to the aluminum. Tungsten has only slightly higher value, double the value of aluminum, but it is used as a high resistance. Why its resistance has been increased means due to very less cross sectional area. If you see the look at this filament, its cross sectional area is very very low. You know that if the cross section area decreases, then resistivity will increase, right? And also it is coiled like this. It has more length. If the length increases, then resistivity will also increases. Both the cases are present here. So due to this very less cross section area and longer length of this filament, tungsten, resistivity become higher. Okay, due to its high resistivity and high melting point, tungsten is usually exclusively used as a filament in the electric bulb. Okay, clear? Then coming to the insulators. Okay, resistivity of insulators. Insulators, you know that it has a high resistance, and it ranges from its resistivity ranges from 10 to the power of 12 to 10 to the power of 17 ohm meters. Okay, it ranges from 10 to the power of 12 to 10 to the power of 17 ohm meter. Next, what about the effect of temperature on resistance and resistivity? You know that this resistance depends upon the nature of the material, then length of the material, and then cross section area of the cross sectional area of the material, right? But the resistivity does not depends upon the length and area, but both this resistance and resistivity depends upon the temperature. Okay, for the good conductors, if the temperature increases, both the resistance and resistivity will increase. Why? Because if the temperature increases, vibration will happen, the electrons will collide with the atoms, and there will be the flow of electrons will be reduced, right? So flow of charges will be reduced. So obviously if the temperature increases, the resistance will also increase. Okay, temperature increases, resistance will also increase. In case of insulators, if the temperature increases, the resistance will decrease. You know that insulators have a very high temperature, very high resistance, right? Why? Because of closely packed atoms. Okay, the electrons are not allowed to move freely in that, right? If the temperature increases, mean the bonds between the bonds, tightly packed bonds, will be broken down, and the electrons are allowed to freely move, right? So obviously the resistance will reduce. Okay, the effect of temperature will vary with the conductors and insulators. Okay, for the conducting material, if the temperature increases, the resistance will also increase. For the insulators, when the temperature increases, the resistance will be reduced. Okay, clear? Thank you.